Hey guys, welcome to the channel, and this is the first part of an injection molding machine that I plan to build. I must say right from the start, I'm not a professional machinist or know anything about plastic injection, so if you're interested in this kind of thing, you can join me, come along for the trip, and let's learn together and let's see how we're going to make this machine, and maybe you'll get some inspiration on how to make it. If you're really looking to maybe buy a machine, I'm getting a lot of inspiration from that Buster Beagle website, but unfortunately it's going to be a bit too expensive for me to ship the parts to where I live in the world. So I've decided to give it a bash and make it myself. So this first part will be the actual manufacturing or making of the nozzle. So let's go to the workshop and let's see what I've done so far. The design of the nozzle is based around this M20 bolt, which is made of stainless steel, which seems to be the preferred metal to use to resist any wear. It doesn't come, or I couldn't get it in any shorter length than 30 mils, the actual length of the bolt itself. So we're going to start off with a 30 mil bolt like that length, and unfortunately the pitch on this thread is also 2.5 millimeters. So it's quite coarse. I don't know if that's going to be a problem in the long run with plastic pushing past it, but I guess we're going to find that out as well. So this is basically the design that I'm going to do. And if we look at it there, it should be about a 14 millimeter hole that I'm going to drill or bore in here for the plastic to go into. It's then going to taper down to the nozzle, which is going to be about 3 millimeters. And then, as I said, the bolt is 20. I've indicated here 21. It's going to have a little area here so you can still basically use the bolt to actually fasten it onto the chamber, and then sort of a semi type of dome here to actually connect to the injection or the mold itself. So the stages of process, I actually don't have that video this time around, but I'll do it next time when I make the chamber. Is going to be to face this off, drill a 3 millimeter hole straight through the center of it, then basically cut this down to 20 mils on the outside, turn the bolt down over here so it forms sort of that shape over there, and then the front will become into a nozzle. Now at the end of that, I turned out like this. So this is the bolt here itself. So that became that, as you can see there. And what you'll notice immediately is that this over here is not 20 anymore. It's now reduced to, let's just get that down there. To 16, just 16.8 millimeters. And you got your 3 millimeter hole in the front there. I did shape that down to sort of form a little injection nozzle area here. I was actually going to do more of a dome, but it didn't quite work out the way I wanted it to, so I actually basically just sculpted that on the lathe itself. Didn't use any fancy methods to create this nozzle point here. And then yeah, you still got the little area there that can be used to actually bolt that onto the chamber itself. So if we go like that, it's just going to sort of screw in there like that. Then there's two issues that happened when I was actually machining this, and that is obviously the length got shorter. And the reason why the length got shorter is because while drilling the 3 millimeter hole through the center here, it actually snapped off inside here, and as it was a cobalt drill bit, instead of remaking the part, I actually started turning down from the outside to the point where I could get the drill bit out, and then I just used a normal drill, which I only had 14.5 millimeter drill bit, and this is just a normal steel drill, excuse me, that actually worked extremely well. I thought I was going to need maybe a cobalt drill to actually drill into the stainless steel, but this worked perfectly. And as I say, it's not 14 now, it's 14.5. And something else I noticed about the 14 or the drilling into this stuff is that, I don't know if you can quite see that, but it's actually pretty round. I thought I'd have to maybe bore this, but I'm pretty happy with the way it actually turned out. And the finish on the inside here, you probably can't really see that, is actually very, very good. So I'm actually thinking in the next video, when I actually start with a chamber, I may not actually bore the chamber, I may just drill it, and then as the result of this was like this. And I'm not sure that it actually has to be to that higher tolerance, as long as the plunger sort of fits in there without too much plastic going through it. So guys, that's the nozzle over here, done and dusted. I don't know if you can see it there. Like I was saying, I got a lot of inspiration from the Buster Beagle website, but he obviously doesn't give any dimensions. That's his intellectual capital. So what I did now is, obviously I did it the way I think it should be, the sizes I think it should be. I'm still a little bit worried about the thread, how coarse it is, and if that'll cause a problem. Maybe if you know, you can let me know in the comments below. I'll really appreciate that. And if you like this kind of thing, maybe it gives you inspiration to build your own machine, please subscribe to the channel. It's obviously going to help the channel grow. And obviously I'll be building a lot more projects like this. In the second video, I'll be doing the heat chamber, and from there we'll build on until eventually the machine is completed. Once the machine is completed, I'm going to use a 3D printer, the resin prints with the high temperature, to make some injection molds. I'm going to experiment with that just to see how that works. That's the idea, or the end goal of this machine, is to use those high temperature resins to make the molds and see how they come out. So guys, thanks for watching, and I really hope to see you next time.